Hi, welcome everyone. We are today going to discuss sniffing, and it is actually the module 8 of the CH course. So, under this topic, we'll be covering these objectives, wherein participants who are joining us today should be able to describe sniffing. Then there are some attacks that are related to it, such as MAC and DHCP attacks. Should be able to explain and describe that. Then ARP poisoning and DNS poisoning are the additional terms that you should be able to describe. And we would discuss then participants should be able to apply sniffing countermeasures, the techniques to detect sniffing, and perform sniffing as part of pen testing. The topics that we would be covering are some of the concepts, then the types and the techniques. We will discuss on some of the sniffing tools, and then under the same heading we'll also discuss the attacks, and then we'll discuss some countermeasures, and then detection techniques and how it is conducted as part of pen testing. So before going ahead, let us first understand what an NIC or a network card is. So a physical card that is actually inside our PCs or computers. It actually looks like something similar to the one that is shown on the screen. So if you can see on the left hand side, it has a RJ45 socket or a port that we actually call it. So the LAN cable actually goes inside this particular port. Then it has an integrated circuit which actually is connected to the PC with these PCI pins, which are shown on the diagram. Actually, an actual image. So it is also called as a network adapter, and this integrated board actually plugs into the internal circuitry of the computer using these PCI connection pins, which are shown. So it allows members of LAN to communicate with each other. So members can be all of the devices which are there on the network, as well as the PC or the host. Dad, physical interface. It is like a physical interface from computer and or a peripheral device to the medium, such as physical cable, twisted pair wiring, coaxial cable, or a fiber optic, or a wireless antenna. So when this particular card becomes part of a PC, it actually is identified with some kind of a identifier, which we call as MAC address by the OS. So what a MAC address is, stands for Media Access Control Address, wherein it is actually a 48-bit number. Okay, and each all 8 bits of the one particular digit is a hexadecimal. So these first three digits, the first three hexas, are actually pertaining to OUI. We call it as organizationally unique identifier. And with the help of this, a MAC address that is there on a PC, we can actually find out the vendor who has created that particular device. So on this particular screen, you can see that I've given you an URL to an OI lookup tool, okay, which is provided on the website by Wireshark. And if you actually input the first three hexadecimal digits, you'll be able to know which vendor actually created that, or which manufacturer has created that particular device. Just a second. And also there is a GitLab repo. If you, let's say, if you want sometime later to make use of these mapped vendor names and the OUIs, then you can actually download it and make it as part of your script if you write it later in future. Okay, so on this URL it is available. So now we know that there is a physical device which we call as NIC, network card, which helps us in communicating with devices over the network, and it has a MAC address. So it has one unique address, which is the last three hexadecimal digits, and the first three hexadecimal digits relate to a vendor who has manufactured it. So what happens in an OS is actually it follows something called OSI model to capture packets on from the network and then process it over the upper layers. Okay, so it follows this kind of a model that just at the end or at the start wherein this card is there and it is connected to a cable, it is called physical layer. Okay, then there is a data link layer, then there is a network layer, then there is a transport layer, then session, presentation, and application layer. So this transport layer is actually the heart of this model. And as you can see with the arrows on the left hand side, that whenever an application tries to send data over the wire, it actually goes through all these layers. And when the data is received on an operating system or on a PC, it actually travels through all these layers. And you can, in the next diagram, I have given that how these the protocols are mapped to the layers. Okay. So as you can see, as soon as the packet travels, it has a header, which is Ethernet header, okay, an IP header, and a TCP header, and application data. But as soon as the data travels up the layers, one of the particular header is discarded, and the data is processed by the subsequent upper layer. So the protocols that we are going to discuss here are the ones that are at the application level. So it's like Telnet, FTP, TFTP, HTTP, and all DHCP. Okay. So we also have discussed earlier the TCP and UDP, which resides at the fourth layer of the OSI model. Now, what actually sniffing is? So it's the activity of capturing and monitoring these data packets from the network over the wire. That particular term is called as sniffing. So what attackers do, they access the entire network from a single entry point if they have access to any particular device which is there on a network. So if they have an entry point, then they can actually pivot laterally to multiple devices as and when required by finding out the vulnerable machines. So there are basically two types of sniffings: passive and active. So attackers compromise either the physical security of a building or a particular compound, or they install Trojan horses or other malicious softwares like malwares, and they can plant these network capturing tools or utilities to exfiltrate that kind of, first to capture and then to exfiltrate that data, but they do it passively without doing any kind of a manipulation in the data packets. But when usually as part of pen testing, whenever it is required for a pen tester, by informing others and IT departments so that they don't get interrupted while during their activities, and actively if it is required for someone to manipulate these data packets, that is termed as active sniffing type. And under that, the attacks which are performed are MAC flooding, DNS poisoning, and ARP poisoning, etc. So what happens in most of these attack types, what you would find in active attacks types, that the mapping between the IP addresses and these MAC addresses is somehow altered. Okay. Or someone tries to impersonate as another device by spoofing. So you would find that, or someone is try to overburden a particular system by flooding with wrong details. So you will find a lot of these examples in the guide, and they have a very detailed the guides have a very detailed account on each type of attack that you can go through. But how does it actually work? How does these packet sniffers work? So now let's discuss how these sniffers work. So on as you can see, this particular activity of sniffing has been basically zoomed out or zoomed in for you. On the in a PC, what happens is that whenever data travels to and fro through these network layers at the layer two, the link, this particular the data is actually captured, and a copy is sent and stored in an external file, such as a PCAP. And then at the application level, another analyzer, a packet analyzer, is kept, and with the help of that analyzer, this data is analyzed. One of the tools that we have been discussing in previous sessions also, and which is Wireshark. Okay, we can have a look at that also. In the lab, I'll cover that. Now, in a typical topology in a network, what you will see is that the PC on which a user is working is actually connected to a hub, and a hub is connected to a switch, and a switch is actually connected to a device called router, and that router is connected to internet. So this is how a topology actually is. We have discussed this under Active Directory enumeration class also. Okay. So now what happens is that if there is a single bus with which PCs are attached, then that is considered to be quite vulnerable to the attacks that we have discussed. And switch is considered more secure a way of keeping the devices communication, uh, keep the devices communicating between each other. Okay. So some of the vulnerable protocols that are there are telnet, http, pop, IMAP, SMTP, and FTP. So wherein all the web applications that you would see actually use HTTP. Telnet services are usually blocked, are not enabled in PCs. But for just testing whether a particular host is live or not, usually network teams sometimes enable it. Then POP and SMTP are related to the email services which are there. POP, SMTP, IMAP. And whenever there's a requirement of downloading and uploading of files as required, then FTP is enabled. So all these protocols actually communicate with or enable communication in clear text, and that's why these are vulnerable, because just by normal sniffing, people can capture that data and read that data packets with the help of an analyzer without doing anything. Okay, without doing any additional cracking or any other methodology such as decryption and all. Then you would see that at the layer 2 of the OSI model that we have discussed, there are some tools called hardware protocol analyzers. Okay, they capture data at that particular layer, and the all subsequent upper layers won't even come to know that such an analyzer has been kept and for sniffing. But usually these kind of devices are very expensive and they are very advanced, and they're out of the reach of individuals such as us and the hobbyists. Okay, or they are usually there with the corporates or the bigger organizations. Some examples are N2X and 5540A, a Agilent protocol analyzer, Keysight E2960B. So, and there are more examples that are given in the guide. Yeah, Bhupendra Kumar has raised a hand. Yeah. Can you please? Yeah, I'll address this query, Bhupendra. Yeah, okay. Okay. Then there is a term called SPAN, okay, which stands for Switched Port Analyzer. So in most of the organizations, you would find that switches of Cisco are being used, and they actually have an additional port, the port that I showed you in the diagram. So a switch usually has these ports, okay, and there is an additional port that is kept for debugging purpose or finding out the errors. What that additional port does is it captures all the data from all the ports, and it keeps it for network people to understand and do some kind of a troubleshooting on it. Okay, it is also called port mirroring. And it is also used for doing some kind of investigations work if it is required. Then there is a term called wiretapping. So it's like if an activity is performed to monitor telephones or internet connections, it is termed as wiretapping. So again, there are two types of like passive and active. So if somebody is passively eavesdropping or snooping on the communication between two people, it is it can be considered as illegal. Okay, and it is very unlawful if you do it without permission. Even the law enforcement agencies do have to collect some kind of a permission before snooping or doing eavesdropping, if at all it is required for analysis, any legal analysis or evidence capturing. Okay, and active wiretapping is also termed as MITM attack. So what is the same thing? Like whenever there is an alteration or injection, data injection between the communication or the or inside the traffic, then it is termed as active wiretapping. And sometimes this is done lawfully by the police or other enforcement agencies. Okay. Now let's discuss some attack tools. Okay. So you would see that on a particular network, usually there is a server which is responsible for distributing the IP addresses to the devices. It is called DHCP. So what it does is it takes a request from the client and it assigns an IP for a limited period of time to that particular PC, and the PC can be identified with that IP address. Okay, it happens dynamically. Now, as soon as that particular PC is removed and the period of that particular IP is over, that particular IP address can be assigned to another PC on the network. So that's the job of DHCP. But it has a limitation. Okay, so it's like that it has some limited number of IPs that can be that it can assign in a particular range. So if you perform some kind of a starvation attack, so it's like you input more number of devices, you try to spoof MAC addresses. Okay, and the DHCP understands it in a different way, and it assigns all the available IPs which are there. Okay, so that way it can actually be it can go under some kind of a denial of service attack. So that kind of a starvation, if it is created, that is called DHCP starvation. And some of the tools that can help in doing this kind of attack is Yersina, Heine, DHCP staff, Gobbler, and DHCP. Then there is an attack called ARP poisoning. So what happens is that there's a ARP table which is maintained between like inside a host as well as inside an internal device which is there on a network, and it has a mapping between IP address and the MAC addresses. So if there are some tools on the network which can actually broadcast themselves as one of the MACs, then they also would start receiving the packets on the network. And these tools like BetterCap, EtterCap, ARPSpoof tool, Metaf, and Kane and Abel, HPing3 also they help in doing this kind of a ARP poisoning. Then like the MAC address concept that we have discussed above, this can easily be changed, especially on Windows. You can go and do registry changes. If you are using Kali or any other Linux platform, then you can modify your MAC address to hide your identity as an attacker. So if you, or you can spoof, or you can basically impersonate as another MAC address on the LAN, so that you are able to capture packets which are meant for that particular machine or a device. You can capture those packets and read them and perform other MITM related activities. Okay. Then there is a term called DNS poisoning. So under DNS poisoning, if you remember, I told you that an IP address is mapped to a domain on DNS servers. Okay, so it's like on all levels, like on intranet also a DNS server can be used, and on internet for the purpose of distribute or like having this mapping on internet, a DNS service is there, like external or internal network. Then on proxy servers it is there. Then on sometimes in the host itself there is a DNS mapping between the IP and the host names. So all of this data at any level, like whether internal, external, or proxies or host, if that particular detail is changed and help an attacker to gain an initial foothold, then it will be termed as DNS poisoning. Some of the ARP poisoning threats which are there and which are quite harmful are packet sniffing, then session and connection hijacking, wherein a user is actually able to hijack an existing connection or a session from an application to impersonate as another user. Then ARP poisoning can also result into VoIP call tapping and interception. Then it can also result into some kind of a data manipulation and also in performing MITM attacks, which are maybe related to theft or denial of service. So these are some of the ARP poisoning threats, and like please read about these details in the guide as well. Okay. Now let's discuss some of the sniffing tools. Okay, then, you might have heard a tool called Wireshark. In one of the sessions, I actually gave a small demo of using the filter or first using Wireshark to capture and select one of the interfaces on the host, and then do a data capture. But in that session, we did not save it inside a PCAP file so that it could be analyzed later with other analyzers. Okay, so these kind of tools are there, and Wireshark is freely available. There's no pro version; it is just open source, and in Kali it is already there. So like I'll just show it to you. Just like it needs actually administrative permissions. Okay, so as you know that I have like interfaces or these cards, some are virtual and some are you know physical. So there is a WLAN 0 card which is there on my machine, and there is a loopback interface also which is there. So I can actually double click it, okay, and this particular tool will start capturing the data, okay, in real time, and then I can stop it, and then we can further look into its data package, the protocols flags. If we are discussing TCP, what all flags are there, what all values are there inside it, and we can like interpret more. Okay, that we'll discuss in the lab tomorrow. So similarly, some commercial versions are there, which you can read about, like Steel Central Packet Analyzer, CAPSA Network Analyzer, OmniPeak, and Observer Analyzer. For mobiles, if you can search it on for Android, actually these are the ones which are given for Android. So the YCAP is there, FaceSniff and Packet Capture are also there. So maybe for one or the other tools, you will have to probably have root access, so that you can completely make full, without any interruptions, you can make use of it. And some might actually require you not to have that root access. Okay, please try these ones, and you might have to connect to a Wi-Fi network for it to understand and capture various details for you so that you can analyze that. Now, for the attacks that we have discussed, okay, one important point is about using hubs or switches in the topology. Okay, I'll just go ahead. So inherently, a switch, whenever is used inside a network, it is actually secure. Okay, but when you try to manipulate the traffic which is going to switch, and you try to overburden it, it actually starts working like a hub. Okay, usually whenever our data travels to a switch, it is meant only for that particular PC because that mapping is available inside a switch. And from one particular port, physical port, to another physical port, there is no exchange of data. But when you bombard this switch with false requests or false MAC addresses, which it is not able to resolve, and that particular data is not there with it, then it starts broadcasting that particular details, those packets. It goes haywire and it broadcasts just like that. And it is possible to basically intercept the data when it travels from one port to another port. It goes into that kind of a hub mode. It becomes like a hub. Okay, or a single bus to which all the pieces are connected. So what happens is, and with respect to NIC cards, you would see that there are normally they are in a normal mode, and they don't capture data which is not meant for them. Okay, but they have one mode which is quite important to understand, which is called promiscuous mode. So when a card is in promiscuous mode, it captures all of the data whatever comes to it. Okay, even if the data is not meant for it, it will be there and can be kept and captured. So all of these sniffing tools, their primary purpose is to do something with the NIC, put them in promiscuous mode, and then sniff for the data, even if the data or the packets are not meant for them. Okay, and this mapping, like with which particular IP a packet should go, and whether it should be processed inside an OSI layer or not, that information is available in the headers, these headers that we discussed. Okay, so now let's discuss some of the countermeasures and how these can be detected. Okay, these kind of attacks can be detected. So let's say you want to not face any kind of a sniffing attack inside a network, then you can actually enable switch port security. It's meant for Cisco devices, and these devices actually give you access a TTY terminal also, so that you can use a tool like PuTTY to connect to these devices and issue commands the way you usually do it for a Linux machine. Okay, then you can configure DHCP snooping and dynamic ARP inspection on these Cisco switches, and that is one of the techniques to counter. Then you can regularly monitor the ARP tables. If you find that there is some kind of suspicious activity which is going on, then you can easily raise a flag. Usually these things are inbuilt in the rule engines of IDS or IPS that you have installed in an organization. But in case, like because you do not have direct access to ARP tables, and it is really really very difficult to detect sniffing. Okay, but in case if you want to, like, you can capture the packet yourself, and but it requires a lot of storage also, so you have to take care of that. Then the protocols that we have discussed, they all have a secure version. Like HTTP has HTTPS, Then we have secure shell. The FTP has SFTP, the secure FTP, and very secure FTP, and then TCP over TLS is there, right? The it stands for transport layer security. Okay. So all these protocols, if you find them, they are vulnerable and they all communicate in clear text. So they can be replaced with these secure versions. Then you can use some detection tools for ARP spoofing like XARP, CAPTCHA that we've discussed, ARPStraw, and SHARP. And it is always best to restrict physical access to any kind of a media which is there in a company. Then you always use end-to-end encryption, that even if some packets are captured and sniffed for later use by an attacker, it becomes difficult for the one to actually decrypt it and understand what was the message inside it. Okay. Then we need to find out some way of keeping the data persistent in the ARP cache, which has the mapping between IP and MAC addresses. Right. It is far more quite detailed. It has a lot of details on time values, uh, and then the duration for which it should be live, and the host name. So all of these details are also there in the guide. Let me just show you there. Just please, read that in more detail as to what all values are there in these tables. Okay. So there are ARP tables and CAM tables which maintain these mapping. So for the purpose of practicals or to actually use them, you would actually most of the time end up using some of the other tool. You might not have to go very deep into the concepts or to directly manipulate an ARP table. Okay. And but for Cisco devices, I think you can see whether free virtualized platform is given in free of cost. If someone is more interested in Cisco devices, then you can have a look at their website also. They give a virtual lab also sometimes, but probably you will have to initiate a request. And also try these tools out by asking the lab access from Vikas, by writing to customers support. I think it's way above. Wait. Just, I should have actually taken a screenshot and I should have put it on the document rather than scrolling it here. But just have some patience and I'll just show it to you. Okay, I think it's an image. It is not a PDF. Yeah, something like this. See, so it's like you have a VLAN, then you have a MAC address, and then the type and the age and the ports to which it is mapped. Okay, our services. So this kind of a table is there in the switches, as well as the in ARP cache you will find a mapping between a MAC address and an IP. So what all active attacks do is like they manipulate and try to disturb this kind of a mapping. Okay, and which actually confuses a particular device or a host. Okay, and sometimes when people spoof, the imposter, so one particular host is actually using some uh, another created MAC address to hide its identity. Okay, so that particular detail gets changed in one of these tables with the switches, and if the ARP cache is being maintained in the host, then there. Okay. So make use of IPv6. It is still not widely being used within the organizations. So rather than using IPv4, it is best to use IPv6, which is inherently considered to be more secure. Okay. So using instead of using hubs, it is best to use switches, and use of VPN is recommended. And then there are some access control lists, okay, wherein you allow only a range of IPs to actually be on the network. Okay, so that kind of whitelisting can be done, and those details can be maintained in access control lists. Then you remember that detecting sniffing is not very easy, because the applications don't even come to know about what goes in the layers below them. Okay, because they are on the top of the OSI model. And having access to tools that can actually capture packets other than the Wireshark, some tools which can capture the packets at the data link layer are very very expensive, and they are quite not easy to be acquired. So this usually happens as part of activities in an organization such as Cisco. Like if you get to have some networking background, then you know. So always check the NSI whenever you are troubleshooting. Check that the NICs are not in promiscuous mode, and they should be in normal mode. Then you can regularly run IDSs, and you can look for MAC changes. If there are frequent MAC changes that are happening, then they can actually give you some kind of an indication that sniffing is taking place. Okay, you can use network tools such as CAPSA network analyzers, and also sometimes you can use ping, DNS, and ARP methods to understand these changes. So let's say if you try to, if there is a PC on the network which looks like suspicious to you, then you can issue these commands with wrong details, and it should be able to accept it without throwing you any kind of an error. Why? Because it is actually meant to receive all the packets in promiscuous modes. Okay, so you can try out these. Some examples are also given in the guide. Okay, please try that out. And also you can use tools such as prompt query and nmap. Nmap has an inbuilt engine to detect these kind of sniffing. Detection is there, a script is there, you can run that against a suspicious host. Okay, so as part of pen testing, perform you can with always with the permission of the owner of the systems. You can perform mac flooding. Okay, you can perform DHCP starvation attack. You can poison the cache or ARP or DNS by using the tools that we have discussed. Or you can spoof the ARP, IRDP. Okay, though this routing is disabled, usually ISMP is disabled in organizations, but try that out. Then DNS spoofing is also there that you can perform. Then once you perform these kind of attacks, you need to document your findings and then report these. Okay, so once you perform these kind of activities, they would help the administrators of the system in doing an audit of the traffic for any malicious content if it is there. It can help them in identifying these sniffing applications if at all they are present. And let's say if they're present, then what all security mechanisms can be implemented. It can help in that. It can also help in finding out the rogue DHCP and DNS servers, okay, which are actually meant for injecting false and malicious packets inside the network and reroute them to an attacker. Okay, then also it can help in discovering the use of unauthorized devices, because unauthorized devices is one of the mediums to actually implant a Trojan, and then quietly sneaking into like using some kind of a exploit or some kind of a payload to actually make a packet sniffer part of it. So say if you want to use Metasploit, then you once you gain an initial foothold, then you can actually run a command called sniffer. So it has a lot of help utilities wherein you can capture the packets, store them on that particular host, extract it for further analysis offline, and then clear your tracks on that. So sniffing usually, if even if it is present only till the lifetime of the rogue devices which are there. So as soon as the rogue devices are removed, the network becomes clear. It is not clogged anymore, right? So it is really, really very difficult for companies or organizations to actually defend. And so prevention is the best method which somebody can take before actually someone can get an entry into the network. So as part of summary, let's discuss. Let me reiterate what we have discussed so far. So what attackers do as part of sniffing, they capture and analyze the network traffic by placing these software that we have mentioned. Now, the software that I mentioned here, you will be able to try that out in your lab. So please ask access for it. Okay. And if you want to use Metasploit, you can actually use the Kali distribution if you have installed it locally, and if you're there having a VM. Then attackers look for sensitive information. So why do they capture these packets? So that they can look for uh, logins, passwords, any chats that have happened or logs they can get access to. It is sniffing is of two types: active and passive. So passive is only observation, active is manipulation and fiddling with the data packets, injecting data, malicious data. Then network layers in the OSI model are independent of each other. So any tool which operates at a lower level of the OSI model, the upper layer won't be able to know whether the sniffing is actually happening or not. Okay, they try to, because these layers are meant to work independently. Then attackers use attacks such as MAC attacks, DHCP attacks, ARP, DNS, and IIDP poisoning to basically overload the systems or create denial of service, so that to change the mode in which these devices are working. The switch goes into bus kind of a hub mode, and then it broadcasts it to all devices, which is actually not its feature, but it's some kind of a fail-safe mechanism for which it is built. So that attackers are able to take advantage of. Then major countermeasures against sniffing is encryption, monitoring, or if there is some dynamically assigned IPs or dynamic allotment of IPs versus MAC addresses happening in ARP and CAM tables, then that can be made as static. So these things will actually help you uh, in defending against sniffing attacks. So just let me show you just one small example as to, without actually doing anything, how you can capture the data over a non-secure HTTP, like the one which does not have it's not HTTPS. Okay. So I have a small sample application that I'll run on the local host. We'll have a lab also tomorrow. So I have this is just sample application. Okay. So what I have is like a small virtual environment for Python, and a framework called Flask App Builder. It helps you in creating, applications very fast. So I've just taken an example. So this is a server which is running on a web application which is running on port 8080 on the loopback address. Okay, the loopback address is the local address of this PC, which is always 127.0.1. Okay. So what is the feature? It has a form. Okay, I'll just log out. So when I try to log in, it has a user and it has a password. Okay, so I'm just showing it to you manually that user logs in. Okay, and as soon as the user logs in, the user is able to see other uh, areas of the application which is restricted for the logged in users. Okay, I'll just log it out. And sorry, I'll just close it first. Okay, so this application server is running, and I'll start Wireshark. And I'll double click this part, loop back hello, and I'll start capture. But it has already started capturing the packet. Now I'll go back to the browser, and in a new tab, I'll go to this address, localhost 8080. Okay, let me check if it is capturing. Yeah, see, it has started capturing the packet on that interface, and then I'll just log in with admin, and I'll give the password, which is actually hidden from a normal user on the form. And then, okay, so once let's say a malicious user has access to a PC on a network, and another user is actually logging into some kind of a banking application, okay, using HTTP and not HTTPS, or any kind of a website over which they have admin rights and they're not using HTTPS. Say we are just assuming that the person is using HTTP, which is a clear text, like a non-secure uh, protocol. Okay, then it is able to capture, let's say, the packets. Okay, so you can go into this filter area and you can just filter all the HTTP requests and see the one which is ready to post. Okay, so if I double click it, I'll be able to see the data here. Can you see it on the right hand side of it? It's there in clear text. Okay, and as you can see that the admin, the parameters which have gone inside the request for username and password are captured. Like username and password are captured here. Okay, you can what you can do is, like, you can just select a particular packet frame, and then you can follow that particular stream. Okay, HTTP stream in Wireshark, and you will be able to read in clear text. So I'm just highlighting that particular row. Okay, so which has username, admin, and password. Okay, so we did not do anything. It's just a non-secure protocol. We just placed a sniffer, and we are able to capture data over a login form. That was just an example using Wireshark. So I think we are, for today's session we are done.